Well, I was really interested in biomedical engineering, and Georgia Tech has the second ranked biomedical engineering department in the nation. A lot of the research is dealing with, working with stem cells or working more on like a chemical base, not like a physiology base. So I wasn't really inclined to doing research, but then I was, thinking about it. I was like, oh, maybe there's something there that I really want to do. So I found this and I was like, oh, this is really exciting. We're looking at how your sympathetic nerve activity affects your autonomic nervous system. This study is looking into is what the mechanism is between the brain and your muscles. So if we can figure out where that mechanism is and what's going on, we can hopefully figure out ways that when rehab for anybody who suffered neurological illnesses, so maybe stroke or anything like Parkinson's or something like that, we might be able to help rehab and that make it easier for them to relearn those motor tasks. So what we do is, as you can see, we have this tank lying on the bed. So we are simulating orthostatic stress. So the stress that happens from if you're lying in bed and you sit up and all the blood rushes from your head. So instead of having people lying down and sitting up, which causes a lot of other variables that we can't really account for, we suck the air out of the tank, which covers them from the hips down, which creates pressure on your legs, which causes the blood to come from your head to your legs. So that increases your sympathetic nerve activity. We use transcranial magnetic stimulation to induce a specific motor activity. And we see what that looks like just under normal situations, their hand at rest without the LBNP tank on. And then we'll go through again, except we'll turn the tank on and see what their motor activity looks like when we have the tank on, so their sympathetic nerve activity is increased. And we'll see what the motor activity looks like then.